This is geotrig lesson 6, day 1. I'm actually thinking we're going to take at least 2 days on this one. Remember that tomorrow we don't meet. We meet on Wednesday for an hour, so be excited and be afraid at the same time. Now, what we're going to do here, guys, is that we are going to solve fractional equations. They're fractions added, subtracted together, and they don't have a common denominator. Which, if they had a common denominator, it would make things a lot easier, because if I had a fraction equaling a fraction, as in a over c equals b over d, this just allows me to cross multiply. A times d equals c times b. That would be perfectly fine. But here, as you can see, I have an addition sign, maybe a subtraction sign down the road. I'm giving you the hint above, and it says LCD. The least common denominator. The least common denominator, did we already talk about that in this class? I know I talked about it in my pre-calc class. I don't think we did. Okay, so we'll go over some steps on how to find the LCD as well. Guys, if I multiply something by the LCD, what's going to happen is that it's going to cancel or get rid of the denominators in all of our fractions. And so, the LCD needs to take the most that any individual has. So how do I go and find that? Let's go some steps here. Finding the LCD. Number 1, I want you to factor the denominators. I want you to factor all of the denominators. Now, our problem right now, and the first couple problems that you guys will encounter, they're already pretty much going to be done. A 7 can't be factored, an x plus 2 can't be factored, and a 3. Once they are factored, I want you to, number 1, write down first denominator. The whole entire denominator. The thing on the bottom. It doesn't matter if there's 1 factor there or 25 factors. You write it down. So for us, LCD is equal to 7. So far, because 7's the first one. I think everybody should agree. Yes? All right. 3. I sometimes like to equate this that we're going to a potluck. And everybody's probably been to some kind of potluck, or everybody has to bring something, right? Now, here's the thing. We all don't want to go to this potluck and have everybody show up and bring baked beans. I mean, so for some of us, that would be a fantastic thing to happen. But most of us would be like, hey, I like baked beans, but not that much. So, this is the rule. The rule is the first person to the party gets to bring everything and anything he wants. This guy brings a 7. He's fine. Now, the next guy, the next denominator, has to bring something different to this party. And so he wants to bring an x plus 2. Is an x plus 2 a 7?
No.
No. And so x plus 2 gets to be brought to the party. And then we move on to 3. Is 3 a 7 or an x plus 2? No. So he gets to bring the 3. That's all the denominators, happens to be in this case, so all of them need to be put together to make the LCD. How do I write that as a rule? You keep multiplying in missing parts. So anything that's not already in the LCD gets multiplied in. The x plus 2 wasn't there, the 3 wasn't there. So, the question gets posed, what if someone already has something someone else already brought? So, let's take a look. I'm going to change the problem. Don't do this, please. What if this guy also had a 7 attached to his x plus 2? Right? We factored out 7, say here. So when he gets to the door, he's got one arm, he's got a 7, and the other hand, he's got an x plus 2. Unfortunately, a 7's already at the party. He can't bring that in. He has to go back to his car, leave it in his car. The x plus 2 he needed here, he could bring in, so that was there. Now, wait a minute. Now the next question comes into play is what happens if the 3 also had an x plus 2, but to the second power? So I'm changing the dynamics of this problem. Get that on film? Now, let's move on to the x plus the 3 and the x plus 2 squared. This guy here wants to bring a 3, and we said, yeah, he could bring a 3 because it wasn't there. He also wants to bring an x plus 2 squared. Now here's the thing. There's already an x plus 2 at this party. Someone already brought the baked beans. But he's like, whoa, guys. He's like, guys, I don't have just baked beans. I have 2 baked beans. And so they're like, okay. You got to leave one outside. You can bring the other one.
Wait, what if they have 3 baked beans?
No, they only have 2 then. Because this guy also gets to bring his extra.
So now we're having 2?
There's 2, yes. As in x plus 2 squared.
Oh.
Okay,
You have to have the most that any individual
So
has.
basically taking the x plus 2 and x plus 2 and leaving out the x plus 2?
Okay.
Yeah, you got it. Yeah.
Guys, okay, listen up. Listen, let me say this. Yes, it's just give me x plus 2 squared. As I said, you have to take the most that any individual has.
Yeah.
This guy only has 1 x plus 2, but this guy has 2 of them.
Yeah.
So you need to have 2 of them. That's what I'm trying to get to. Don't get hung up on the fact that it's baked beans because we're going to a potluck, okay? It's everybody has to bring something different, and if they bring something that's already there, they can't bring it. But if they have more than one of it, they get to bring the extras. It's a hard thing to kind of grasp around. But once you get the idea, it's like, oh, the person who has the most of something individual object gets to bring all of theirs. The others then don't get to bring theirs. Okay, now I went back to the original LCD before we started messing with it. And how we use this LCD. Those steps there are just to make it or find it. Because then now what I'm going to do is I am going to take the LCD and I'm going to multiply both sides by it. Oops, it's the other way around, but it works. I multiply basically the whole equation, both sides. Can you guys see that this one on the left will have to be distributed in?
Yep.
Now, there's a couple ways we can think about this. You could say, I'm going to multiply both sides by that LCD, or, bless you, you can multiply everything by the LCD. Guys, I basically just distributed the 7x plus 2 times 3 in. So everything on the top in the numerators have it. The reason I like this method is because now I can cancel and I'm allowed to show it. Like the 7s will cancel. The x plus 2s will cancel. And over here the 3s will cancel. And then all you do, guys, we just got rid of all the denominators. So now I just rewrite it. There's a 3, there's an x plus 2, and then I think there was a 4 left. Right? Plus a 7, a 3, and a 3. Can you guys see that? Because the x plus 2 just went away. And then what's the last one? A 5, a 7, and an x plus 2. So, now what I'll have to do is multiply. By chance, what is 3 times 4? 12. And 12 times x? And 12 times 2? 24. What's 7 times 3? Times 3. So plus 63. 5 times 7? Times x. And then it times it by 2. Gathering up like terms, 12x plus 80 equals 35x plus 70. I'm going to bring the x's to the right side and the numbers to the other. Minus 12x minus 70 and minus 70. That's what, 23? Oops. Let's just do 87 minus 70 is 17 equals 23x. Divide both sides by 23. X is equal to 17/23. Not a nice number, but that is it. Guys, there's one last thing, or two last things you got to worry about. Number one, does it check out? Put the number back in. Yes? That's number one. Number two, guys, there's actually an x value that this can never be. What would that x value be that it can never be? Has to do with it right here. AJ.
-2.
Why can it not be -2? That is correct. What happens when you put -2 in for x? Jan? Yeah, you divide by 0. Can you divide by 0? No. Ask Siri. Okay, something about adding 0 friends and dividing 0 into 0 friends, you get nothing. Or something on those lines.
You still have no friends.
You still have no friends, that's
You
right.
started off with no friends. So you never get no.
Okay, next problem. This problem, guys, you can treat it the same way as saying, hey, we do have some denominators, because the first one is that way, but the second problem deals with decimals. I think the second equation is pretty much a little easier to deal with. We don't like decimals, so we get rid of them by multiplying by numbers or groups of what? Multiples of what moves decimals? By tens. Yes. In this case, I don't want to multiply both sides by 10. I want to multiply by 100 because I need to move 2 decimal places at most. So, yes, the second equation, I'm going to multiply the whole entire thing by 100. Now remember, this is getting distributed all the way across, guys. So when I move the decimal, it becomes 3x. It becomes minus 20y equals a negative 37. That's not too bad, right? But that top one, I'm going to move that lines out of there to get so I can see it again. The top one, I've got not common denominators. I need to multiply both sides by the LCD. What happens to be the LCD of this problem? It's 35. The only denominators is a 5 and a 7. 5 times 7 is 35. So I'm going to multiply everything by 35. I don't know why I put parentheses. You don't need to because I'm multiplying everything by 35. What's 35 divided by 7? It's 5, and 5 times 3 is 15x. 35 divided by 5 times 2? 14. It's 14y. And 35 times 11. last one here. Because 35 is the LCD. I got rid of all the denominators this way. 35 times 11. 35 times 10 is 350.
355.
385 is it? Someone back that answer.
385.
Now guys, you just created a system of two unknowns and two equations. Now you just need to solve for x and y. What's going to be our best option? Substitution, linear combination.
Substitution.
I don't know if I like substitution. This is why. This is the only reason why. You can use it, guys. It will work. Think of it. To get substitution, guys, I have to get an x or a y in either one of these equations by itself. Which means I'd have to divide both sides by 3, or a 20, a 15, or a 14 in the second equation, right? Can I guarantee, first of all, is 20 divisible by 3? Or is 3 divisible by 20? Well, is 37? No. So that means none of these are going to be a good option to make nice numbers. Does 385 divisible by 15?
Probably.
Possibly. What about 14?
No.
Possibly, but as in 385 divisible by 14, but they definitely are not divisible into each other, are they?
No.
So you're going to be left with some ugly looking fraction that you're going to have to substitute and deal with. I think using elimination might be your best option. I say multiply the top equation by what?
5 by 3.
Not 5, but
Minus 5.
a negative 5.
But you can like, you don't have to.
They can, yes, get the same coefficient but opposite in signs so you can add them together. Negative 5 times 3x is negative 15x. Negative 5 times negative 20 is 100y. And negative 5 times negative 37 is a positive 185. Add them, sorry. They're gone. We engineered that to happen. 114y is equal to 570. That's a 185. I got a little extra line in there. Divide by 114, divide by 114, y is equal to 5? Is it 5? 5 something? Is it just 5? That would be pretty cool. It's just 5. Now, guys, we need to solve for x. If I was using substitution, I would have x equals something, but I don't. Just plug in y. Now, which equation do you want to put it in?
The first one.
Way up here? This one?
Yep.
I do not. This one? No. I would use one of the nice equations. Right. Right. No, the other say I did that on purpose. I wanted to make sure, make a point that we can use any of the modified equations. So, 3x minus 20 times 5 is equal to negative 37. Did I do something?
No.
So 3x minus 100 equals a negative 37. 3x equals, because I can add 163.
Yep.
And I can divide that by 3. No problem. 21. Now, guys, we're talking about solving a system of x and y. We should probably write it as an ordered pair. So what would the ordered pair be?
21.
Right. Homework, guys. Lesson day 1, lesson 6, page 52. 1, 4 through 7, 10, and 27. Have a great day.